You've probably heard the claim that every cell in your body replaces itself every 7 years. So technically, you're a completely different physical person than you were a decade ago. That claim is almost right, and completely wrong at the same time. And the real answer is stranger than either version. For decades, nobody could actually test how fast human cells replace themselves, because there was no reliable way to date a living cell inside a living body. You can date a fossil, you can date a tree ring. You cannot, under normal circumstances, look at a neuron sitting inside someone's skull and know how old it is. Then, in the early 2000s, a Swedish cell biologist named Jonas Frisén at the Karolinska Institute realized that the Cold War had accidentally solved this problem decades earlier, without anyone noticing. Between 1955 and 1963, above-ground nuclear bomb testing released enormous quantities of carbon, 1.4 into the atmosphere, roughly doubling its natural background level. That carbon, 1.4, got absorbed by plants through photosynthesis, entered the food chain, and became part of the DNA of every human and animal eating those plants. When the Test Ban Treaty ended above-ground testing in 1963, atmospheric carbon, 1.4, began falling at a known, measurable rate, having roughly every 11 years. Frisén realized that every time a human cell divides and copies its DNA, it locks in whatever level of atmospheric carbon, 1.4, existed at that exact moment, like a tiny time capsule. Measure the carbon, 1.4, trapped in a cell's DNA, compare it to the known atmospheric curve, and you can calculate almost exactly what year that cell was born, accurate to within about 2 years. What Frisén's team found when they finally applied this to human tissue overturned decades of medical assumption. Fat cells, they discovered, turn over constantly, and the rate isn't fixed. In people with obesity, fat cells were being replaced faster than in lean individuals. Roughly 10% of the body's fat cells renewing every year, regardless of body weight, meaning even in obese patients, the total number of fat cells stays remarkably constant. They just get replaced more rapidly. The skeleton you assume is a stable structural chassis is, at the cellular level, being actively rebuilt around you constantly, at a rate that responds to your metabolism. Then Frisén's team pointed the same method at the heart, a muscle doctors had long assumed was fixed for life, incapable of generating new cells after childhood. The carbon, 1.4 data told a different story. Heart muscle cells do renew throughout adulthood, just extremely slowly. About 1% of cardiomyocytes replaced per year at age 20, dropping to roughly 0.3% per year by age 75. Over an entire lifetime, less than half of the muscle cells in your heart are ever replaced. Most of what's beating in your chest right now, if you're over 40, was built before you learned to read. And then came the finding that settled a scientific argument that had been running since the 1960s. For decades, one camp of neuroscientists insisted adult brains could generate new neurons throughout life. Another camp insisted the adult brain was fixed, that you were born with essentially all the neurons you'd ever have. Frisén's carbon 1.4 method could finally test this directly, tissue by tissue, and the answer turned out to depend entirely on which part of the brain you asked. The visual cortex, the region processing what your eyes see, showed carbon 1.4 levels, matching the birth year of the person exactly. Zero turnover. Those neurons are the same physical cells you were born with, for your entire life, never replaced, never rebuilt. But the hippocampus, the memory center, told a completely different story. Frisén's team calculated that the adult human hippocampus generates roughly 1,400 new neurons every single day, a number that stays remarkably stable from young adulthood well into old age. So somewhere inside your skull right now, two completely different timelines are running simultaneously. Neurons in your visual cortex that have existed unbroken since before you could speak, and neurons in your hippocampus that are, on average, only a matter of months old, constantly being replaced by neurons that don't exist yet, which raises the actual question buried underneath the 7-year myth. If some of your cells are decades old and some are only weeks old, existing in the exact same body at the exact same moment, what does it even mean to ask whether you're the same person you used to be? The parts of you responsible for raw visual perception, literally the physical cells doing the seeing, have been with you since infancy, unchanged. The parts of you responsible for laying down new memories are, right now, mid-replacement, built from neurons that will themselves be gone within a couple of years. You are not one age. You're not even one timeline. You are a composite of tissues running on wildly different clocks, some frozen since childhood, some rebuilt faster than you can consciously register, held together under a single continuous sense of me that has no single cellular home to point to. Frisén himself has noted something almost poetic buried in the data. The reason the visual cortex and a handful of other tissues never renew appears to be that some circuits are wired so specifically, so precisely, that swapping the physical hardware would risk losing the information encoded in exactly how those cells are connected. The brain seems to make a trade-off, cell by cell, region by region. Some structures are worth freezing in place forever to protect what they hold, and others are worth constantly rebuilding because what they hold needs to keep changing. So when you ask where the old you went, the honest answer is nowhere, and also almost everywhere. Some of that person is still physically inside you right now, in the exact cells that first learned to see color and light. And some of that person has already been quietly disassembled and rebuilt dozens of times over, one hippocampal neuron at a time, without you ever noticing the handoff. The you reading this sentence is not one age. You are several ages, layered inside the same skin, and the oldest parts of you have been sitting there, completely unchanged, since before you could remember anything at all.